Okay, folks, so we have just discussed GMP, good manufacturing practices, GLP, good laboratory practices, and now we're going to talk about GDP. No, not gross domestic product. And if you put gross domestic product in the online quiz, that means that you have Googled the crap out of these answers, and that's the first thing that's going to show up. All right, so GDP, according to this class and in reference to us, is good documentation practices. Now, this is kind of like a subcategory of GLPs. That's what these are, because it is how in the laboratory do we document things. So when we generate laboratory data, how are we supposed to do that the proper way? Where does it get recorded? How does it get saved? How do we write it down? What do we do with the reports? That's what good documentation practices is all about. So it is connected to GLP, but it's a subdivision because there's an entire series of little regulations that go on in here about what these third-party people like to see. So if an auditor comes on board and an auditor begins to take a look at my laboratory notebook or the data that the laboratory generates, what would they like to see as prim and proper? So one of those things that we've already really talked about is an SOP. So we talked about standard operating procedures, and we have to have standard operating procedures. It has to be there, right? And the standard operating procedures are helping us to ensure that we are following GLP regulations, good laboratory practices. I mean, that's why we have SOPs, because it helps the laboratory process and work the proper way. The issue, though, is that SOPs do not, and I repeat, do not prevent all mistakes in a lab. This is really up to the analyst. It's up to the employee. So the person that reads the SOP has to follow the SOP. And as long as they follow the SOP the proper way, we can get pretty good data, but mistakes can still happen. Or if they don't follow the SOP and they know they're not following the SOP as it written, well, mistakes are going to happen. That can also be a problem if we're not really careful. So there should be an SOP for everything. We've already talked about this, but this is part of documentation practices because this is a document that the auditors are going to want to see. And they want to make sure that these documents are in place so that way when their workers who are in charge of generating data for the company, they need something to follow. What are they going to follow? This is a staple. It's a foundation. It's a basic. It has to be there. So the SOP should be for all of it, folks. Everything's got to be documented, right? That includes how to handle and store chemicals. So when the chemicals arrive at the facility, where do we keep them? Do they go in the fridge? Do they go in a prep room? Do they go in a general stock room? Do they go in a warehouse? What goes on? How to perform the method and the process. These are step-by-step directions of how to do the actual testing. They're going to look for that as well. There should be SOPs for that as well. How to use the instrumentation required for the testing. So there should be an SOP for it too. If I've never used that machine, I hope there's some kind of reference document that I can use to tell me which buttons test where and what goes what. Next is how to generate data. So once I get this instrument up and going and once I get it to start generating data, okay, how do I get the software to be used? How do I get the software to save? How do I get the software to print? How do I get the software to send it to somewhere else that's going to permanently record it? There should be an SOP for that. That goes hand in hand with how to store data and reports. Do I print these off? If so, an SOP better be there, and it better tell me how to print it off, and it better tell me where it goes, and it better tell me what type of printer to use. Those SOPs, okay, well, if I don't print it, it's got to be stored. Do I store it at that computer? Do I save a copy of it? Do I give it to somebody else? Do I send it to an email client? Do I, network it to another master computer in a LIMS system? What goes on? How to use the software. That includes things like Excel. So once I get data, once I get reports, there's going to be numbers. What do I do with those numbers? Do I just upload them and send them to somebody else? If so, what do they do with them? Or am I responsible to do something with those numbers? Because I guarantee you, whoever I send that report to is going to have to do something with those numbers. There better be an SOP in place. Auditors are going to look at that because that's documentation. So how to use Excel? Step by step. How to use the equipment software? Step by step. It better be in place. And then finally, how to dispose of waste. Also an important SOP. It's important of the documentation purposes. They'll want to see this. When I don't need that reagent anymore, do I dump it down the drain? Do I put it in a trash can? Do I put it in a steel container and kind of have it ready for pickup for disposal? What goes on, right? When I complete the test, I don't need anything else from that. I get all of this other waste. Where does that waste go? Same type of deal, same type of scenario. For documentation purposes, there's often a rule of thumb. If you didn't write it down, it never happened. I'm going to repeat that again. If you didn't write it down, it never happened. I'm going to repeat that again. If you didn't write it down, it didn't happen. I'm going to repeat that again. If you didn't write it down, it never happened. I can't stress that enough. So this is really the thing that aggravates most people in the lab. It aggravates me. All right? I'm just being honest. I have to write down every freaking thing that goes on in a laboratory. So when I'm doing a test, when I'm generating data, when I'm compiling a report, when I'm putting things in spreadsheets, I should have a laboratory notebook. And I should be writing things in the laboratory notebook. Now, different companies will handle this in a different way. It might actually not be a notebook. It might be an individual sheet of paper that you will record things on, but you have to write things down. And you give that sheet of paper back to them and they'll store it the way that they need to be stored. But you get the drift. We've got to be detailed. We have to be detailed enough where we have to provide as much information as possible, but at the same time, we don't want to overdo it. There's a fine line between those two things. There's a fine line where I am just rehashing and regurgitating the same old stuff over and over and over. That's something that I don't want to happen. But there's also a point where I have to detail as much as possible. Because if I did not write down the statement, I did not do that particular task or that particular step. So the documentation motto here is, number one, say what you do. If I'm doing a step in a lab, I'm going to write that step down. Just because it is step one in an SOP does not mean that I followed it. That just means it's step one in the SOP. I better write down, I did step one, right? I mean, not exactly that way. But if step number one says use a 250 ml beaker to measure out 100 mils of water, then in the documentation side of the house, I better say what I did. I obtained a 250 ml beaker. I filled it to the 100 mil line with deionized water. That is something that I've got to write down. If I don't write that down, I didn't do it. Who cares about the SOP? Just because it's written in the SOP doesn't mean that you actually followed it. Next up, do what you say. So if you write something down, you better have done it. Meaning, don't get into the habit of writing a task down on a sheet of paper and then forget about doing it. Or just don't do it at all because you've become a creature of habit. You've done the same thing over and over and over and over and over. You get into the habit of writing the same thing over and over and over and over and over. You don't want to do that. So you have to make sure you do what you actually said that you did. Next up, we've got to come up with a way to prove it. So proving it basically means what can we add to the document to show that I did my job the right way. So for instance, if I measure out something using a weigh boat and a balance, I can actually add in a receipt ticket. And that receipt ticket helps prove that I measured out what I wrote down. All of that needs to be tracked and documented the proper way. Next up, we have to improve it. So, are there loopholes that we are actually going in or using? Is there a way that we can improve our process to make sure that those loopholes are not being taken advantage of or that are no longer present? Can we completely eliminate those mistakes? We constantly look for ways to improve documentation and laboratory practices. Next up, I want you to understand that you are legally generating legal documents. These documents that you are making, that you're recording, that you're writing, it has your handwriting on them, you made that document. You can be called to a courtroom. You can be called to testify in a courtroom proceeding. You will be asked a series of questions. Be ready. Fully understand what you're doing, because those documents can be pulled at any point in time. Good documentation practices can include many things. Of course, it is SOPs. That's proper documentation. Labeling on bottles, labeling on reagents. This is bath, but it should be batch. Batch production records. On the manufacturing side of the house, they have made a batch of stuff. That should be documented. That should be kept. That's a GDP requirement. All the data that's generated by the laboratory has to be saved. All of the equipment use. This in turn connects to logbooks. Who used the equipment? When did they use it? What time did they use it? Why did they use it? That equipment has to have documentation. The logbooks have to have documentation. The alarm logs. Let's say I've got a refrigerator in the laboratory that should be kept at 4 degrees. At 5 degrees, let's say an alarm goes off. That is a problem. That is something that needs to be documented. That's something that needs to go into a logbook. I need to record it. I need to write down what date did it happen, what time did it happen, what was going on at the time to cause that problem to happen. That's an alarm log. Finally, training records and shipping and receiving. So training records we talked about already. Anyone working at these facilities, your training records have to be saved. Next up is shipping and receiving. They need documentation as well. What came to them? When did it show up? How did it arrive? Where did they put it? Who signed off on it? What was the state of that material like when it kind of happened in-house? Good documentation practices. We live in an electronic world now, so this can be electronic, meaning you can type on a keyboard certain things as long as various policies are in place that prevents you from reopening an electronic document and saving over an electronic document. You can use a computer. You can write things using a keyboard for documentation purposes. Not a problem. They're okay with that. It's just got to be done the right way. And next, you have to ensure that that lab notebook or that document cannot be removed from the lab. Meaning if I'm working for a company and I'm writing things in a lab notebook, that lab notebook is not mine. I'm writing in it. I'm writing what I'm doing in it. But that is not my property. That is the company's property. So that property has to stay at the facility. You cannot take a lab book home. You cannot modify a laboratory notebook once you get it to your house. You cannot write in a laboratory notebook at midnight or 1 o'clock in the morning because you probably aren't doing work at midnight or 1 o'clock in the morning. So the notebook stays in the area that you're working in. That notebook never leaves. That notebook is only written in when you are actually doing work-related tasks, and that is it. And you do not own it. You are responsible for it, but you do not own it. Good documentation practices will lead to something called ALCOA. Another abbreviation! Yay! Something else to remember. What does ALCOA stand for? ALCOA, the A stands for attributable, legible, contemporaneous, original, and accurate. Let's talk about these quickly in a little bit more detail. ALCOA, attributable, means who acquired it, who did it, who printed it off, who generated it. That way you can assign a person who is responsible. That is attributable. Next is legible. Can I actually read what that person wrote down? That is good documentation policy. You've got to be able to read it. If you have horrible handwriting like me, you're going to have to work on it. Contemporaneous means record it when the action was done, not after the fact. And I'm going to say it again, not after the fact. You've got to record it as you do it. You have to. Next is original. Original means source data, and source data is actually no photocopies. You can't destroy the originals. If that's the sheet of paper that came from that instrument, you've got to keep that sheet of paper or that receipt ticket or something in a form, in a binder, attached, taped, stapled permanently, something, right? You've got to keep the originals. They cannot be photocopies of the originals and then throw the originals away. And finally, accurate. Accurate means you've got to take responsibility to help ensure that they are correct and truthful and complete and valid and reliable. It's got to be legitimate, right? It can't be made up. As far as data integrity goes, if it can't be made up, how trustworthy is it? This is actually one of the most common and increasingly observed mistakes. If somebody's going to get written up, it's going to be in the data integrity side of the house. So in other words, they got pretty much everything else in place. They've got the documentation policy, great. They've got the SOPs, great. They are storing documents in the proper way, great. But at no point in time are they showing how they are keeping the integrity of the data, valid. So what are you doing to help ensure that this report or this data does not get modified in the future by someone? Well, this is actually one of the most common problems that auditors begin to see. How do you ensure that it's complete? How do you make sure that the person is attached to it from the time it's generated to the time that it's saved? How difficult are you making it, because it should be, on changes to the reports or changes to the raw data as it's getting generated? We don't want changes to happen. It is what it is, and I should not be able to go in and modify or do something to it. How are you ensuring that someone is properly reviewing it and securing it after it gets saved into the database system or after it's filed in the filing cabinet? These are all areas of good documentation practices. All right. This is also, again, one of the faults that companies normally slack on because they do not have the integrity process in place. They don't have this ready to go for an auditor to review it. All right, so in the next video, we're going to take a look at some of the document and journal rules that I should be following as I'm writing things up in a laboratory environment. There are some things that we have to do. We have to ensure that they're done the proper way, and it's a whole big old list. So I might as well start that in a new video, so that way you can take a refresher if you need to, go take a potty break, get a snack, pop some popcorn, maybe drink a beer or a glass of wine, and then come back, but only if you're over 21, and then come back. And we'll talk about it a little bit later. So document and journal rules is what's up next.